We can get started by introducing Ellen. I'm sure that people will keep joining. Welcome to the CIIR talk series, and my name is Zamani, and today it's my pleasure to host Ellen Voorhees. I think Ellen needs no introduction. She is a fellow of NIST. She manages the Text REtrieval Conference, or TREC. She's a fellow of ACM. She's a member of the ACM CIIR Academy and a fellow of the Washington Academy of Sciences. I'd like to read a part of her bio that talks about her current focus at NIST. Currently, she is examining how best to bring the benefits of large-scale community evaluations to bear on the problem of trustworthy AI. Voorhees general research focuses on developing and validating appropriate evaluation schemes to measure system effectiveness for diverse user tasks. So without further ado, I'd like to ask Ellen to share her slides and talk about Coopetitions or IR evaluation. Please join me.
Okay, thanks very much. Let me get back to sharing. Okay, there we go. Everybody should see just the slides now, right?
Perfect.
Good. All right. So thanks very much for the invitation to talk here today. And as you just heard, I'm going to talk about coopetition in IR research. Before I do that, I'm going to give you a little bit of background on NIST. I am at NIST. NIST is the National Institute of Standards and Technology. It's part of the U.S. Commerce Department. So it's a federal agency that's part of the Commerce Department. And its basic mission is to use measurement science and standards as a way of advancing technology to improve the U.S. economic security and quality of life. And I'd like to say that if NIST had a patron saint, which it doesn't, but if it did, it would be Lord Kelvin, who is quoted as saying, if you cannot measure it, you cannot improve it. Right? So that's sort of NIST's focus, is on being able to measure things. NIST is really into measuring things. It created a set of trading cards for the set of 7 international units, basic units, along with their major nemesis, major uncertainty, right? I mean, so NIST really takes its measurement seriously, but it doesn't only measure physical artifacts, right? So NIST is a place where the U.S. elects atomic clock, so the clock for the U.S., that's a NIST product. It also does a lot of measurement of biotechnical products and chemistry, but it has actually also had a long history of human language technology measurement. On the right here is a cover of a technical note, which is from, well, NBS, which is the National Bureau of Standards, which was the prior name of NIST. And it dates to 1963, and it's a report on information selection systems of the state of the art of the time of 1963. On the left there is a picture that was used in one of the NIST's reports, historical reports about the problem with water goats. This was again a 60s era translation, automatic translation work, and the problem was that they kept coming across all this mentions of water goats within their technical reports that were being translated, and finally they traced it back to hydraulic rams were being translated as water goats. But nonetheless, NIST has had a long history of evaluating human language technology as well with all the other stuff that it measures. And so in that context is where TREC started. Right? TREC is the Text REtrieval Conference. It started in 1992 with the explicit purpose of trying to build large test collections to evaluate, at the time, to evaluate the systems that were participating in the DARPA Tipster program. And since 1992, it has built more than 150 test collections for all sorts of different tasks, and we'll get into some of that later on in this talk. There's been hundreds of participating teams worldwide. One of the focus that I want to make on today's talk, though, is to talk about it also being a venue for determining how research gets done in these particular areas of the focus areas or the tracks that were in TREC. So why am I calling these coopetitions, right? TREC is not the only, they're community evaluations, and TREC is not the only instance of it by any means. There's also CLAY and NTCIR and FIRE in information retrieval. But Wikipedia calls defines coopetitions as a cooperative competition, right? And I like this emphasis on cooperating competition for TREC because while competing can give you a bigger piece of the pie, it's actually the case that cooperation makes the whole pie bigger, right? And that's what we're trying to focus on. We're trying to focus on, TREC is trying to focus on supporting the retrieval community by giving it the infrastructure that it needs to focus on this research. And as I mentioned earlier, TREC is not the only one that does this in IR. But the rest of my talk is going to be focused largely on TREC because that's the one I'm associated with, and that's the one I know best. And so we'll talk about coopetitions, but in specifics, it will be mostly TREC specifics. Now, the main, not the only, but the main benefit of coopetitions in information retrieval specifically has been the construction of the test collections. The coopetitions actually develop infrastructure that includes more than test collections. It also is the task definitions and the methodology, but it's the test collections that have really spurred on the research, and it was the original reason for these coopetitions to exist. And so I want to actually spend a fair bit of time here in this talk going back sort of the state of IR evaluation from the beginning of, or at least what I'm going to call the beginning, so the beginning of the fields when the Cranfield paradigm became a thing. All right, so the Cranfield tests, this was circa the 1960s. The Cranfield tests were a series of experiments run by Cyril Cleberton, who was trying to compare indexing languages. And so this was not actually computer-driven indexing languages, right? These were the, Cyril Cleberton was a librarian, and the librarians at the time were having wars, basically, about which way humans should use, what types of vocabulary schedules should humans use when they were indexing books and other articles. And he decided that he was going to do a head-to-head comparison among a different set of indexing languages. And the way he was going to do that is he built what was the first to be considered a test collection, which is a set of documents, set of queries, and then relevance judgments that say which document should have been retrieved for which query. Cyril Cleberton's original focus for the Cranfield test was not actually on this creation of the test collection, although that's pretty much what it's remembered for now. And it was this use of relevance to decide whether or not a document should be retrieved or not, right? That was the definition of relevance. It was really vilified in the literature at the time. And there's been this periodic recurrence in the literature ever since then of being vilified for basing the entire evaluation structure on this thing called relevance, because relevance changes both over time and from people to people. But nonetheless, the field persisted, and in jump ahead about 10 years, and then Keith Van Rysbergen and Karen Spark-Jones made a proposal to the British Library to build a new test collection, which would be considered at the time to be very large. It would have 30K documents, right? Which was immense at the time. They decided that they should have at a minimum 75 what they called requests, Trek would call topics. People might think of them as queries, right? These information needs at the time. So 75 requests over a 30K document set. And they introduced the idea of pooling, which we'll get into in a little bit later. This idea of pooling to get the judgments, right? Because one of the things that Cyril Cleverton thought was absolutely necessary in building a test collection was that every document had to be judged for every query. And if you do that, you're going to have very tiny collections because humans can't look at that many documents. And so Karen and Keith proposed in this ideal test collection proposal to use this idea of pooling to get to not look at every document, but only look at the documents that are probably important to look at to get the relevance judgments. This proposal was not funded, but about 6 or 7 years after that, Karen and Steve Robertson wrote a book, or Karen was the editor of a book that Steve also had a chapter in. And this was basically reflecting on 20 years of test collections. And there's a couple of quotes here I have on the slide, and you can read those quotes, but essentially, Karen and Steve at that time, 1981, were not so happy with the state of IR evaluation. And Steve in particular was arguing to have a portable test collection, which later on in my talk, I'll talk about a general purpose test collection. And the idea there, for Steve, at least in this quote here, was that he wanted collections to be built purposefully rather than just by whatever happened to be around and the real problem was that people at the time were using collections that had been created for some other experiment, but it was the only thing around, and so they were using it for their own experiments, whether or not it really fit the particular experiment they were trying to do. And so Steve was arguing that we should have a general purpose collection. All right, so another 10 years goes by, and Jerry Salton wrote an article in the Information and Processing, a special issue of IPM on evaluation of IR systems. And in that, he laid out what he saw as the case that people were still making against Cranfield and rebutted a lot of those things. But the case against Cranfield came down to 3 main things, even 30 years after Cranfield first started, which were relevance judgments, right? People were still unhappy about relevance judgments because they vary too much between people and over time. That topical similarity, which is basically what a relevance judgment in collections are, is not the same thing as utility, and it's utility that we really care about. That static judgments can't represent a user's changing information need. Then there's this other problem that recall, which is, you want to know all of the relevant documents for a particular query in this document set. That's essentially unknowable, either because of size or because all the other problems of relevance that whose recall are you actually trying to say? And in fact, that people don't really care about recall because if there's too many documents, they don't want to see them all anyway. And there was also this problem of that results on the test collections of the time were not representative of the operational retrieval systems at the time. And that was largely because they were just too small. The test collections were just too small. Nobody running an operational retrieval system, which at the time were the Meads, the Mead data and the LexisNexuses of the world. I guess PubMed, no, what is it? Medlars at the National Library of Medicine. Those were all the operational retrieval systems, and they were just too large, and nobody there believed that the results that were being shown on test collections had anything to do with their real problems, just because the test collections were just too small. So in that 10 years between the 80s and 90s was somewhat of an IR winter, in the sense that the retrieval results being published by different research groups weren't comparable to one another, because people were using different measures. And the real problem there was not only that people were using different measures, it was that the people were using measures that were called the same thing, but because they were implemented differently, they were actually different measures and weren't comparable to one another. And so different research groups couldn't build on one another's work because you didn't actually know what was really happening. And this lack of realism impeded the technology transfer between the research community and the operational systems. So within all of that period, it was in 1992 that TREC was born. And TREC was basically a direct response to this feeling that the community had sort of lost its way, and that there should be a better way of supporting the research by building better collections. And so the first goal of TREC, these are the 4 goals of TREC that were issued at the time in 1992 for the first TREC. This is what this was: to build large test collections. The meaning of large has varied throughout the years, and we can see some of that later on in this talk. But also to be a place to exchange research ideas, right? To bring people together, to have them talk about what's going on, what's going right, what's going wrong, to speed technology transfer through that same process by the exchange of research ideas and having people develop methodologies that would work on real world problems, and also to standardize the way that people were evaluating their systems, and to develop new evaluation techniques if they were more applicable for the size or for what the change in the task. So those were the 4 goals of TREC at the beginning, and they were a direct consequence of what was going on in the research community at the time. So TREC was successful, actually, frankly, in obtaining those initial goals, at least for what we called at the time the ad hoc task, which was the classical IR task of you have a set of documents you have that the system knows, you have incoming stream of queries, and you want the system to retrieve a ranked list of documents from the collection for this particular query, ranked in order of what the system thinks is decreasing likelihood of relevance. TREC eventually, and pretty close to the beginning, got into this the process that TREC used to develop these collections. I have here on the slide, and it's pretty much generalized to all the other IR coopetitions as well. Although this particular slide with the idea of the assessors at NIST is clearly specific to TREC. The way that we start a track or a task within TREC is we have these humans, which we call the assessors. Most of the assessors are retired information or intelligence analysts. They come to NIST with with some ideas of what queries they would like to investigate. TREC uses the word that differentiates between queries and topics. The topic is an information need in natural language prose, in English prose, where the query is the data structure that is given to a retrieval system. Okay, so the topics are sent out to the participants. They return a ranking of documents for each of those topics. when those results come back to NIST, NIST forms pools, which we'll get to in a moment, from the unique documents. It's a sample of what the different systems have returned. And we show that pool to these human assessors who created the topic to get judgments for that topic. We then use the judgments that these assessors create to evaluate the retrieval systems. And then everybody gets together in November, in Trek's case, to talk about what went wrong, what went right, what worked well, and also to plan for the next year. And so the cycle continues. It's also the case then that the annotations, which are the relevance judgments mostly, and the data and the results and the scores, it all gets archived on the Trek website. And then that archive itself becomes available for people to do research over. Okay. So one of the main contributions of Trek was Trek Eval, which is the standardized implementation of the evaluation measures and the methodology about how it is that you're going to score a ranked list. And one of the things that came out of that then, once we had all these different retrieval runs and we were scoring all these different retrieval runs and looking not just at the average scores, but the individual scores, was that variance across topics is huge. Okay, and to the chagrin of evaluators, the variance of topics between topics is so large that it's actually larger than the difference in systems, right? So what we would like to measure is the difference in systems, but in fact, the variance in topics, so how easy and how difficult an individual topic is, dwarfs those differences in systems. And so you have to be careful of how you do your evaluation. And the main way that IR evaluation takes account of this variability is to make sure that what numbers get reported are averages and not the scores for individual topics, because an individual topic is just too noisy, a score is just too noisy of a thing to make any conclusions on. Right. And I have an aside here on the slide that just says commercial search engines, and in this case, basically, I mean the web search engines, have enough different user sessions that they can control variability in other ways. They don't necessarily have to use averages over large sets of topics. I mean, they do sometimes, but they don't have to. But for the classic test collection paradigm of doing evaluation, pretty much your only way of controlling this variability is through averaging. All right, so why are we using test collections? What, you know, why do we do research in this way at all? And I have 3 points here. One is that test collections have been shown, that the results from test collections have been shown to predict the performance in real use cases, right? So test collections have sufficient fidelity to the real user task to be informative. They're abstract enough, though, so that they're broadly applicable, right? They're much more broadly applicable than some very specific two-system comparisons that you might want to make. And so they're general enough to be broadly applicable, to be feasible to implement, and actually relatively inexpensive to create, where relatively inexpensive, of course, depends upon what you're comparing it to. But if you weren't going to be using test collections, then probably what you would have to be doing is user studies. And user studies are much more expensive than test collections. To do a good user study is much more expensive. You definitely lose realism when you're using test collections, right? The whole point is that these test collections are an abstraction of some real search task, but you lose that realism in order to gain control over a wide variety of variables, and therefore you get more experimental power at a lower cost. And so community evaluations, then, one of their main points is to build these test collections And it's these test collections that have been built that have led to a significant improvement in the state of the art, right? So that's one of the benefits of community evaluations, is that it does improve the state of the art. But community evaluations offer a couple other advantages also, some of which I have alluded to before, but their community evaluations are a place where a research community either gets started or at least solidifies, right? If you have a task within TREC or within CLAY or CIIR, that generally brings a critical mass of people who are looking at the problem, and so that the research gets there's enough people doing the research that it feeds on one another, and it really establishes the research community. It's also a place where you can establish the research methodology, which is how do you do research on this problem, right? And methodology includes such things as what measures are sensible for this task. What is the good abstraction of this task? And so what does your test collection look like for this task? Once you have a research community and the methodology in place, those components then facilitates technology transfer. And it's not only technology transfer from the research to the operational systems, but it's also transfer among different research groups, both in academia and in industry. And the final benefit of these community evaluations is that it amortizes the cost of the infrastructure, right? So infrastructure does cost things, it's not free. But if you can have more people use it, then each individual use is less expensive. And so that's why TREC has focused on creating the reusable general purpose test collections, so that people could use, so not only do people who didn't participate in the TREC track that built the collection, they can use it, but also that people could use it for other things that was not necessarily the main focus of the track in which it was built, but that it would be a good surrogate for whatever this other problem was. So a big part then of the research that goes on at NIST, or at least lately, has been this question of, okay, if we want general purpose reusable test collections at acceptable cost, how do we go about doing that? And the first answer in the early TRECs was that we did that through pooling, which I will define in the next slide. But let me just focus a little bit more here again on what it is that I mean by these words. For general purpose, I mean that that's a collection that supports a wide range of different evaluation measures and a wide range of different search scenarios. No single collection is going to be appropriate for every task that you can think of, but we would like it to be we want it to be fair to systems that did not, well, that's my next point, it's reusable. We want a collection to be enough different scenarios so that it gets enough use so that the costs are amortized well enough. By reusable, we mean that it's unbiased for the systems that did not participate in building the collection. And that will become somewhat more clear once I talk about pooling. And we want it to be acceptable cost. I mean, acceptable cost basically is whatever you can fit into the budget that you happen to have. But for the purposes of the remainder of this talk, I'm going to make cost directly proportional to the number of human relevance judgments that are needed. Like, there are some other costs, but they're all dominated by the number of judgments that you need. So pooling, I've already mentioned this a bunch of times. So here it is what it actually is. You assume that you have a lot of different diverse runs, or run is the output of a retrieval system, and that you have a wide variety of these different runs, and you're going to take the top some number. For TREC, that number was usually 100. You're going to take the top 100 documents from each system's ranked list, you're going to throw those documents into the pool. You're going to reorder the pool, and you give that pool off to the assessors to be judged. The main point in pooling is this assumption, and it's an assumption that's wrong on occasion, but this assumption that if you have enough diverse systems and you make your lambda here, the depth that you go into these rankings deep enough, that you're going to get essentially all of the relevant documents, right? Because these systems are ranking their documents with the relevant are supposed to be at the top. So if the systems are at all good, you should see the vast majority of the relevant documents at the top of those rankings. And you won't have to look at any other documents, and you can assume that any document that was not judged is not relevant. And for the early treks, we could show that the resulting collections were both fair and reusable, right? So they were fair in that the systems participating in it were evaluated fairly, but also that the systems that weren't used in the construction could still be compared to the systems that were used in its construction, and that comparison was still legitimate. So the state of IR evaluation in 2002. So this is now 10 years after the Sultan's report and this IR winter in the beginning of Trek. Was a lot of work on showing that Cranfield was valid, right? So we showed that it was noisy. It is noisy because relevance judgments do change, and depending upon who you ask as the assessor, and even with as stark as an abstraction as we have in Cranfield of the user, it's the user. So that means this relevance judgments and what questions they ask is still the biggest variable. And we looked at how many topics do you need in order for these averages to be reliable. And the main upshot of that was that Cranfield was noisy, but it was valid as long as you used enough topics, where enough topics was certainly more than 25, 50 was better. But the main effect of all this noise was that you could only use it was only valid for comparative results, right? You had to be comparing two different retrieval systems on the exact same test collection, and that a subset of a test collection was a different test collection, right? So you couldn't take, for instance, a subset of the topics and compare scores computed on a subset of the topics to scores computed over all topics, because that's an invalid use of the test collections. So that was sort of the state of the art in 2002. And this is out of order, chronological order, but I want to put it here. Is because just this year, Jimmy Lin and Ian Soberoff and I took a look at the Trek 8 collection. So Trek 8 was 1999. It was probably the best in terms of it had the most judgments of any of the ad hoc Trek collections. So it had a lot of judgments. But we made this claim here back in all throughout Trek, in the early years of Trek, that pooling was legitimate, and that it created reusable collections. And so this year we went and we got 5 new runs. These were runs produced by Jimmy. They were all neural runs, right? So, well, 3 of them were neural runs, and 2 of them were just re-implementations of BM25 as a baseline. And the idea for this experiment was we wanted to show that these neural runs, which couldn't possibly have been contributing to the pools that were built in 1999, right? Because the whole retrieval system paradigm had changed for these neural runs, could be fairly compared on the Trek 8 collection. So what we did is we created new pools for those, because the neural runs did retrieve some documents that had not been judged. But we didn't want to only look at those documents because that skews the collection in the other way. And so we went back to some of the old Trek 8 runs that had not been pooled, and we pooled the old Trek 8 runs plus these new runs. We created new judgments, different assessors, because it was 20 years ago. But we got new assessments. We found there were new relevant documents, 158 new over the whole 50 topics of new relevant documents were identified. And there was one run, one of the transfer runs had 23 new relevant documents in it. 23 relevant documents over ranked lists of 1,000 for 50 topics is a vanishingly small number. And so what you see here on the left is the Kendall tally of the systems when they were evaluated on the one hand with the old Trec 8 collection, and on the other hand with the old Trec 8 collection in union with these new judgments. And for anybody who's looked at any of my other work, you can see that's an astonishingly straight line, right? That is no difference to talk about at all. And even more importantly, even if you looked at individual topics, those are stable as well. And so I claim that this is really strong evidence that in fact the early Trec 8 or the early Trec ad hoc collections really are reusable. They really are, the pooling really did work in that case. Now somebody can come back and say, but wait, we have an even newer, even fancier system. You can't, how do I know that it's fair for this system? I can't conclusively prove that it will be unaffected. You couldn't be able to do that unless you judge all documents, and you aren't going to judge all documents because that would take literally years to do. But it's really incredibly, vanishingly unlikely for some new run to be significantly unfairly scored. And the reason for that is that new run would not only have to retrieve a bunch of new relevant documents that hadn't been seen before, but it would also have to rank those runs, those documents, before all the ones that we do know are relevant. And some system being able to do that, it just, I will claim that it's just not going to happen. So I think that the early Trek collections are really reusable. All right, let's pop back chronologically now. And so mid 2000s, we again are looking at the state of IR evaluation, and you'll see that there's sort of the same sorts of complaints that are still being made in the literature. That relevance judgments are poor models of searchers. That was from a workshop at Glasgow in 2006. And that's the slide, the picture of the slide on the left here on this slide is my response to that. That yeah, test collections aren't great, right? They're poor models of researchers, but in fact, they're better than all the other alternatives we have. And I still believe that. There's also the complaint that recall is unknowable. It's still true, but it's also an important, I will claim that it's an important measure to look at, because systems that completely ignore recall tend to be less generalizable than those that don't. There's still the claim that results in test collections aren't representative of operational retrieval systems. And so this is a couple of papers from Bill Hirsch, and I don't remember Turpin's first name, sorry. But anyway, I will claim actually that that's not true, that what their experiments actually showed is that it's really hard to do user evaluations, and that their user evaluations weren't large enough. And then there's been more recent complaints from Norbert Furr, who's been saying that IR evaluation is just methodologically unsound, and we should be doing completely different things. In the face of this criticism, what has Trek done? Well, Trek has sort of just continued to march along, trying to build at least test collections, and validating the methodology that is being used by looking at the outcomes with the Trek results. So in 2005, there was a paper by a bunch of NIST people and Chris Buckley that actually showed that where pooling did break, right? You made this assumption that if you have the top some number, say 100 documents from each run, you'll get the vast majority of relevant documents. Well, as the document set sizes continue to grow, that becomes less and less tenable. And in fact, at some point it breaks. And we were able to show that in the Trek robust track in 2005 collection, which was also the hard track collection in 2005. And the problem is just that there are so many, in the larger collections, there are so many relevant documents that all sort of look the same. These easy to retrieve relevant documents fill up the pools, and you never get to the hard but relevant documents, and you never see them. Part of that examination and also what Justin Zobel did in 1998 was to develop this test called the leave-out uniques test, which tries to show when a collection is not good. And the idea in a leave-out uniques test is pretend that some system didn't participate in a given trek, and so we wouldn't know that their relevant documents are relevant. And evaluate all the rest of the systems with and without their documents. And if you see big changes, then you know the collection has problems. That's true. You do know that the collection has problems if you see big changes. The problem is if you don't see big changes, you don't actually know that the collection is okay, because you just don't have, maybe you just don't have the systems to demonstrate that there's a problem. So I'm going to go through the next couple minutes very quickly some of the ways that we've been trying to build reusable general purpose test collections now that pooling is broken. Can we fix it, or can we do something else? And one of the first approaches to doing something else is actually inferred measure sampling, right? So these are, instead of using straight top 10 or top 100 samples of the runs, sample differently so that you can compute these measures, these inferred measures, which are provably an estimate of the true value of the measure. It's just you don't actually know sort of how big the error is there in that estimate. And in fact, the quality of the estimate varies very widely depending upon how you do your sampling strategy. But it is fair, right? So it's the systems that are participating in the evaluation are treated fairly, but it's unclear how reusable they are, just because of the sampling would have been different had different runs been in the process. There was also a suggestion to use multi-armed Bandit sampling. So in this case, each of the arms of the Bandit are these different runs. And what you're trying to do is you're using Bandit techniques to trade off between exploring good arms, going down deeply in good runs that are retrieving lots of relevant, and exploring to go find maybe even better runs. So in the collection building, each arm is a run, and the reward is finding a relevant document. And there's been a bunch of papers that look at in simulation showing that you get similar quality test collections, similar quality to pooling, but with many fewer judgments. And so Trek 2017 Common Core Track took a crack at that, building a test collection from first principles using Bandit techniques. And in order to do that, we needed to implement a practical Bandit approach, which meant a couple of things. First of all, we had to solve the problem of how does an assessor learn a topic, right? In these Bandit techniques, once a judgment is made, it's used and you can't change it, and it affects everything that moves on. But that's not how human judges work, right? They have to sort of learn a topic first, and sometimes they change their mind, and now what are we going to do? And then we have to decide how, among an overall budget, we're going to allocate budget to individual topics. And so we tried different things within that track. And the main point I want to give you here is that the Bandit methods can be unfair. So they don't even treat individual runs that are participating in the evaluation fairly, because if your budget is too small, and you don't know how too small your budget is, if your judgment is too small and the Bandit method just keeps taking documents from runs that are returning relevant document, then it's basically a starvation attack against all the other ones, which would also be returning relevant documents, except you don't ever get there because your budget is too small. And we never actually did come up with a very good practical means for coordinating budgets among assessors. So then in 2019, we started the deep learning track in TREC. The main purpose of the deep learning track was to look at retrieval systems when there was lots of data available to train. And that data came from the MS Marco, from the Microsoft MS Marco data set, which meant that there was a very large, hundreds of thousands of queries, each with one judgment. And so the idea of the TREC track was then to compare sort of more standard TREC type evaluation, which had 50 topics but much more deep judgments, to this hundreds of thousands versus one. And we used a process called continuous active learning, which was out of Waterloo, to select documents to be judged. So it is an active judgment process in the sense that you don't know which document you're going to judge until you get the judgment for the current one. But it's selected differently than Bandit methods. And in 2019 and 2020, we got a collection that was okay, where okay, the collection quality is being defined in terms of the leave one out uniques tests and sort of other poking at the collection. And oops, I think I skipped too many there. But in 2021, it fell apart. We did the same thing in 2021, but the collection was very much worse than it had been before. And the question is how come? And the answer again is size. Yeah, so that the collection was so big that we never actually got enough of the collection judged within the budget to be comfortable that the collection is reusable. And in fact, the collection is not reusable. The leave one out test shows that. And to make matters even worse, not only, so normally what happens when you have a collection that's not reusable, you say, oh, well, at least the runs that were participated in the TREC track are being evaluated fairly. And in 2021 deep learning track, even that's not true, because there are so many relevant documents that you have to rely on shallow measures like precision at 10 or NDCG at 10. But there are so many relevant documents that those measures are saturated. The average score was close to the median precision at 10 and NDCG's 10 for each of these, this is across topics, was 1 for more than half of the precision at 10 score median was 1 for more than half the topics, which means the whole evaluation just is unstable because there's no way to differentiate among these systems, because any differences, any observed differences are likely just noise because the evaluation is so unstable. So what are we going to do now? Is this the end of Cranfield? Can we not build Cranfield collections when the document sets are that large? Back when we broke pooling, that paper suggested 3 different things. One was to form pools differently, one was to engineer the topic set, and the other was down sample to the known relevant set. All of those are still options, but they all need more research. And so none of them are clearly obvious what to do next. Yeah, this is just sort of a recap of why we use Cranfield and what we wanted to do. But the state of the art in collection building right now, there's no single best technique when your collection gets too big. That too big is defined in terms of number of relevant documents, not in terms of number of documents overall, which means, of course, that you don't know whether a collection is too big for you to do until you try. You need to and therefore you need to reserve some of your budget to do overall quality control, and because the only way that you can do quality control is to get more judgments. And then these dynamic methods, so both the Bandit methods and also the CAL, do have potential cost savings, but a lot of those cost savings is blunted by the practicalities of doing things in real use, like the fact that the assessor has to learn the topic, and you need more to test the quality of the collection. So that is it. I will say that this creating the test collection, large reusable test collections, is still is the current research that I am doing, and that other people at the NIST retrieval group is doing.
Okay, great. Yeah, thank you, Ellen, for the very nice introduction of like where the trek started and where things are now. Please join me to thank Ellen. So we have about 7 minutes for questions. I see that the first question in the chat is from James. James, do you want to ask it yourself?
Sure. Hi, Ellen. So I just
Hello,
trying to
James.
think of something vaguely interesting to ask. So one of the things I'm curious is whether there are variations of retrieval measures or additions to retrieval measures that could say, given your run, which has a lot of unjudged documents at the top of the rank list, let's say, just for simplicity, there may be a problem with the stability of this particular collection, or your system just is terrible. But I'm just wondering if there's ways to flag that, and if people have looked at that sort of thing.
So I have two answers to that. One is just the straight count of unjudged gives you some idea, right? Especially if that count is 0, right? So even if there is tons of unjudged relevant documents, if you aren't retrieving any, then this collection is fine for you.
Right.
A more principled answer to that is the rank bias precision measure that Alistair and Justin introduced probably 10 years ago now, is trying to do precisely that. It at least it builds a bound on how your measure could have changed, whether if the unjudged documents were judged. And so, I mean, it bounds it both up above and below by assuming that the unjudged documents are both not relevant. All of them are not relevant, and all of them are relevant, right? And we've used, we being Trek has used this measure in a couple of places, and including in Trek COVID, which is where we had judged pretty tiny top judgments. The main issue I shouldn't say I have. My experience with these measures is that their bounds tend to be so large you don't have any actual conclusion, just because it's almost always can't tell.
It's like the NRC rankings of computer science departments.
Right.
Thank you.
Okay, thanks. Is there any questions from the audience here? There's not, so I'll go through the chat. And so there's another question from Shashara. Shashara, I'm not sure if I understood your question, so I think it's better if you can ask it yourself.
Sure. So I was wondering on like slide 31, where you were speaking about like Bandit methods for selection of documents for judging. I was wondering, and you said that they were unfair against even the runs that were, generating those ranked documents. So I was wondering if this unfairness was like only in terms of like recall measures.
No, it's a short answer. It was all measures.
I see.
Because what's actually happening is all of the Bandit methods, at least that was suggested at the time and that I used, had this property that they stayed with a run. As long as that run returned a relevant document, the next document selected was from that run. And if you have a budget B and that particular run retrieves B or more than B relevant documents in a row, then the only place you're going to take documents from is that run. Whereas all these other runs also could have had relevant documents, you just never got over there to look. Now you can do some other things, right? You can throw in a small probability that even if it does return a relevant document, you go elsewhere. But you're always going to have this problem that the budget has to be larger. The budget of the number of documents you're going to judge has to be larger than the number of relevant, or else you're in trouble. And you don't know that until you start judging, because you don't know how many relevant documents there are until you judge. So one of the things you can try to do is estimate the number of relevant documents that there will be with a smaller sample. And we've tried some things there too. That's just, again, a pretty noisy process, because if you knew how many relevant documents there were going to be from a small sample, then you would only just use that small sample. It's
Okay, thanks. So I want to ask a very generic question. So when we look at the past 30 years of like tracks, there are trends on increasing the collection sizes or introducing new tasks with different queries or sessions and things like that. I'm wondering, what do you like to see in the future of tracks? What do you think is missing and the community hasn't focused on as kind of organizing tracks and track?
Well, as a evaluation nerd, I still think this idea of how to evaluate on large collections still needs attention. We certainly haven't solved that problem, but not everybody needs to, right? I mean, so at this point, large is really, probably hundreds of millions, if not billions, of documents, right? We're getting in that range, and that's only one use case has things that tend to be that large. I mean, not one use case, but there's a small set of use cases that are large. The other sort of things that is happening in Trek and in other places, but is still pretty early in its trajectory, are conversational systems. All right, so these are systems that support more than one-off questions, right? So you're actually trying, so there was an earlier track in Trek called the sessions track, which actually tried to do some of that too, of grouping a series of questions and improve retrieval performance over the whole set of queries because of the context of the session. There's now also explicitly conversational, which it tends to be shorter turns, some sort of back and forth, explicitly being targeted at things like Alexa and Siri and Google Home sorts of things. That's really challenging both to do, but also to evaluate, because now, once again, you have put a lot more of the user back into the evaluation. And being able to get enough instances of cases where you see the different phenomenon across the different systems to be comfortable in your evaluation, that's just really, really hard. And I guess that also brings up some of the tons of things that we've been trying to do throughout the history of Trek, and we still don't know how to do well, frankly. Our evaluations that include humans in the loop, sort of more abstractly than full-scale user studies, but less abstractly than full-scale user studies, but more concretely than Cranfield. People have been after me to try and do something in that sphere for a long time. The Trek Interactive Track tried to do that and basically concluded that, yeah, it's really hard. really difficult. And then James started the hard track a couple years after that and tried to abstract away from the humans, but have sort of categories, and people would fill in template, sort of forms that would describe the user somewhat. And again, the conclusion there was that we just couldn't get enough instances to make reasonable conclusions across systems within the budget that we had. And to some degree, this conversational evaluation is going that same route, because again, humans are integral to that whole process. But doing that evaluation well and rigorously is really challenging.
Okay, great, thank you. Thanks, and thanks everyone for coming.